Good afternoon, scholars. Today we're doing section 10.3, and it's our last section where we're talking about the properties of parabolas, but we've got two more things that we need to talk about. So what we're going to start out with is this example that we actually did, I believe, in 10.1, where we just had to graph the function f of x equals x squared. So I just copy and pasted this slide in here and don't write it down again. But what we're going to do this time is we're going to look back at it and we're going to ask ourselves, what were all of the inputs that we had and what were all of the outputs that we had? Now be careful because this table gave us an idea, but it did not list every single input and every single output, right? So we used these inputs as our test inputs. We used -3, -2, -1, 0, 1, 2, and 3. And these were the outputs that we got for those test points, okay? So we got this point right here, we got this point right here, all of these guys. But were those all of the possible inputs we had? No, there was nothing stopping us from doing another input. We could have input 4 here, and we would have gotten the output 16. And that was totally valid. That is an input and that is an output that we could have gotten. What about if we had done the input 0.5? So if I had done the input 0.5, what would I have gotten? Well, what's 0.5 times 0.5? That's going to be 0.25, which is actually on our graph, right? It's right here. So there were more inputs than we see here, and there were more outputs than we see here. But we can see all of them on the graph because that's why we connect it. We connect it so that we see all of the in-between points. And even though I don't see 416, that's why we have this arrow here because it's really up here somewhere. So this arrow is indicating, oh, and it keeps going upward, right? So if we are asked about what are the inputs and the outputs, all the possible inputs and all the possible outputs, what we really want to do is look at the graph. And this graph is going to help us see much more easily all of the possible ones we could have had. So for the inputs, remember that's our x values. There was nothing stopping us from doing any number here. We could have plugged in -50. We could have plugged in 1,618. It would have taken us all the way this way or all the way this way, and that's okay. So there was actually no limit on our input. So our inputs were all the numbers that are possible. That's my cat running around in the background if you can hear that. So remember, we can use this symbol right here, this all real number symbol. But the outputs, well, was there any possible way that I was going to get a negative number here? No, and our graph even shows this because there's nothing down here in the y's. All of our y's are up here, right? They're all positive numbers. And that makes sense because it's a squared, right? No matter what, if you take a number and you square it, it's going to be positive. So our outputs were actually all numbers that were 0 or bigger, only positive numbers. So what I'm going to say is y, because our outputs are y, is greater than or equal to 0. All numbers bigger than 0. So there's a fancy word for this, for all possible inputs and all possible outputs. And those words are domain for the inputs and range for the outputs. Okay, let's practice looking at some functions and figuring out what the domain and range are. It says graph the function using Desmos, identify its domain and range. So I'm going to go to Desmos and type in y equals x squared plus 4. All right, so y equals x squared plus 4. And here's our graph. What I'm going to do is I'm going to turn on change my step to go up by ones. All right, that looks better. All right, so here's what our graph looks like. So we need to find the domain and the range. So domain and range. All right, remember, domain is x values. So for the domain, I'm going to look at my x values. This is my x-axis down here, and I'm going to ask, well, what are all of the numbers where we have something going on in our graph? Now remember that there are really arrows right on the ends of this. We could have zoomed out and seen much more of this graph. And no, there's nothing stopping us from going all the way this way. And if we had zoomed out far enough, eventually we would have gotten something on our graph up here. It would have taken a while, but there is something going on all the way down here at -10 or whatever, or even down at -100. And same thing if we had kept going up on the positives. So for our domain, there's nothing stopping us. We could do all of the x values. So our domain is all real numbers. All of the numbers work. But for the range, I definitely see that we're going to have stuff going on 4, 5, 6, 7, 8, 9, 10, 11, and up beyond that. But there's nothing going on below 4, right? So for the range, we need to stay 4 and above. So for my range, I'm going to say y is greater than or equal to 4. Let's do the same thing for example 2. Identify the domain and range for this function. So I'm going to go to Desmos and type this one in. Y equals 1/2 x squared minus 16. And here's what we get. I'm going to zoom out on this one a little bit. And I'm going to change my step to go up by 2s. How about that? Okay, awesome. All right, let's list our domain and range again. All right, our domain is the x value, so that's going along this axis right here. So I see I definitely have stuff going on between -6 and 6, but if I kept going to the right, am I still going to have more stuff going on? Yeah, because really there's an arrow here, and it's not going straight up. It's kind of going like at a diagonal, so there is going to be more stuff going on in that direction. Same thing with going in this direction. This is not going straight up. It's kind of at a diagonal. So yes, there's going to be more stuff going on over here. So there's no limit here. We could go all the way to the left or all the way to the right. So our domain, again, is all real numbers. For our range, there is definitely a limit here. So yeah, I see stuff going on up here and then infinitely in the upward direction. But if we go down, there's stuff going on all the way down to -16, but nothing underneath it. So for this one, we need to stay above -16. So for this one, we have all numbers. Y is greater than or equal to -16. All right, take a second to copy example 3 down and try this one on your own. Okay, so here's what this one looks like when we graph it on Desmos. And there's a couple things that I want to point out. So you'll notice right away that this one's kind of been shifted over to the right, right? And some of us might think, well, maybe that's going to affect my x values because we're kind of moved over on the x-axis. But we still have no limit on our x's, right? So yeah, we can go, and it's harder to see when we're zoomed in like this. We could go 3, 2, down to 1. Remember, the first number is the x. Or we could go up 5, 6, 7, 8. There's nothing stopping us from going even farther. And in fact, if I zoom out and if I change my y-axis to go up by a much bigger number, let's change our y-axis. Let's make the maximum like 5,000. So now it's squished and it's much easier to see, like, yeah, it's just going to keep going all the way to the right and it's just going to keep going all the way to the left. There's no limit for our x's. Up to 150. We could go all the way up to 2 million. There's nothing stopping us. But then for the y-axis, this one is easy enough to see. We can go all the way up to 10, and then that's it. We're never going to be above 10. So for our range this time, we have all numbers that are 10 or less. All right, so again, for our domain, we have all real numbers. And this time for our range, we have numbers that are less than or equal to 10. Okay, actually write this question down in your notes. It asks you, how do these two parabolas appear different? And they give us f of x equals 1/3 x squared and f of x equals 4x squared. All right, so I've got my 1/3 x squared showing up in red and my 4x squared showing up in blue. So what's the difference between these two graphs here? Well, I noticed that they start at the same point. You know, they have the same domain and range. They have the same vertex. It's both the minimum. They open the same direction. The only difference that I see is that this one, the red one, is a lot wider than the blue one. And so I would say the red one is wider and the blue one is narrower. So I would say that this one is wider and this one is narrower. Well, what do you think is causing that difference? I mean, the only thing that's different in the functions themselves. is this one has a 1/3 here, and this one has a 4 here. And so that number out front of the x squared is always going to change how wide, or the width, of the parabola. The coefficient on the x squared term affects the width of the parabola. And let's make a little note here. If it's a bigger number, like this one had the 4, it's actually going to make it narrower. It's going to make it skinnier. All right, hopefully you're ready to move on. So we have 2 examples that are going to ask us to do this. Order these functions from narrowest to widest. So go ahead and write it down, and then we'll talk through this one together. So what we need to do is look at the coefficients, right, on our x squared terms. So we know what the negative does out front, right? The negative just flips it upside down, and that is not going to affect how wide it is. So what we can do is just kind of ignore the negatives, if there is one for right now. So we're just looking at what the coefficient is. So this one, we really have a 1 here. This one we have a 3. And this one we have a 1/3. So of all of these, let's start with the narrowest. Which one is going to be the narrowest, the skinniest? Well, that's going to be the biggest number. So this one right here is going to be our narrowest function. Up next, well, between this one and this one, the bigger number is 1, so this is going to be our next one. And that means that this one, since it has the fraction, is actually going to be the widest. And if you're ever in doubt, go ahead over to Desmos and check what these look like. So sure enough, I typed them in, and the one that's the narrowest one is this red one here, which is the 3x squared. So the biggest number was the narrowest function. The middle one is this one, the negative x squared, and the widest one, the green one, is the 1/3 x squared. So yep, Desmos confirms what we thought. All right, do example 5 on your own, please. All right, and then here's what you should get. This is our narrowest. It's the skinniest because it has the biggest coefficient. This one's in the middle, and this is the widest because it has the smallest coefficient. So you learned 2 new things in this section, domain and range, and you also learned how to determine how wide the graph is going to be based on the coefficient.